Okay, so I want to take a break from talking about the interesting world of vectors to prep you guys on exam 2. Now, this will be used as a distance course supplement, and they may have a completely different exam schedule, and they may ask completely different questions depending on who you're getting. But these are the kinds of questions I ask, and I guess you can get some comparison on how rough your teacher is, how easy they are. And these are good problems. You should know how to do these by now in this course. Okay. Problem number 1, it says sine of x is equal to square root of 3 over 2. Let's look at this. And cotangent of x is less than 0. They want us to give the exact value of tangent x. And what they mean by this exact value is write it as something like this without using a calculator and round off. Okay, so first we need to draw a picture. If you use your calculator, you will find that if you arc sine this, well, I suppose we'll do it. It's 60 degrees or the square or pi over 3. But if you didn't know that, and like I said, I've been trying to get you guys to know certain values of angles that just show up a lot. Well, I won't even use my calculator. I know it. In the first quadrant, it's the sine of pi over 3 is the square root of 3 over 2. So let's draw a picture right here. And this is what I was talking about, why it's important to be able to draw these pictures. And this, when you get into calculus, it's really going to matter. It's not going to be so important about what the exact values of these things are, but being able to draw these pictures and figuring things out. So here's angle x. I know that this is pi over 3. It's 60 degrees. So we also know, though, okay, so it says cotangent of x is less than 0. Cotangent is what? It is going to be cosine x over sine x, that this is less than 0. So here's the deal, though. Cosine and sine are both positive in the first quadrant. This is the first quadrant. This is the second. Because I see that this cotangent x is less than 0, I'm already figuring I need a different picture, but remember what we can do here. Okay, so what is this? If I start here, this is pi, get out of the way. If I'm backpedaling this way, I want this to look like this. This is pi over 3, so this is pi minus pi over 3. This is 2 pi over 3, or 120 degrees. And remember what that means. We measure around this way. So here is your 60 degrees. And here is your 120 degrees, or pi over 3 degrees and 2 pi over 3 degrees. Here's the way that we measure it, but this is the picture that we're going to use, right? Now, let's figure out how to decompose this. We can do this a couple things. We can make this on the unit circle or not. I know that I'm not going to use the unit circle this time. It wouldn't matter if you did, if you wanted to. You'd get the same exact answer. But let's look at it. So sine is this divided by this. This is opposite divided by hypotenuse. That means that this must be 2. This must be the square root of 3. This must be 2 squared minus the square root of 3 squared. Basically, this is 1. Okay? And this is from Pythagoras. And I've done this like a billion times. So you should be okay with it. I hope you're okay with it. Similarly, that means that this is 2. This is also the square root of 3, but this must be negative 1, right? Because it's on this side of it. So you'll notice that the sign of this is still going to be the square root of 3 over 2, but the cosine of this, which is usually 1/2, so the cosine of pi over 3 is 1/2. The cosine of 2 pi, yeah, that is right, 2 pi over 3 is negative 1/2. And that means that the cotangent of 2 pi over 3 is going to be less than 0. Okay, so now what is the problem we're actually solving? We're looking for the exact value of tangent x. And so this is the picture we're going to make it from right here. Tangent x is this over this. The exact value of tangent x is going to be the tangent of 2 pi over 3. Now the tangent of 2 pi over 3 is, we're going to use this picture right here. It's going to be square root of 3 divided by -1. It's just the negative square root of 3. And incidentally, what they meant by exact value was they wanted you to draw this picture. And okay, so why am I saying they when this is a test that I wrote? I am more physics friendly than a lot of math professors, and physics people use numerical approximations and calculators all the time. To some degree, in physics, this answer doesn't have a lot of value because it doesn't really say numerically what it is unless you happen to know the square root of 3 is about 1.7 and some change. But what they really want you to know, and what most of the people that write the questions in the books and what most of your other professors are going to want you to be able to do, is to draw this picture. And when you get to calculus, you'll be really happy that you can draw this picture. Now, as it happened, if you are as brilliant as all my students are, and actually the class that I have that I'm making this for, they really are, they would have just used their calculator to spit out this as a number. But I wanted to make sure that you guys could draw this picture, and that's why I'm using this word exact in that context. So that's that. I guess we're going to do problem number 2. Okay, so problem number 2 says, find the radian measure of the central angle theta opposite an arc S 27 meters in the circle of radius R equals 18 meters. Right away, word problems, blah. Incidentally, I didn't write this myself. I usually take test questions out of your book in the later sections. Like I tend to assign all odd problems because the answer's in the back of the book. So what I will do is I will take even problems that were, on the interesting side of your homework problems, and I'll put these on your test because I think this is a good way to measure. What did I just say? Always read word problems twice. Find the radian measure of the central angle theta opposite an arc S 27 meters equals 27 meters in a circle of radius R equals 18 meters. Okay, so let's draw a picture. All right. So here we have this. We have a central angle opposing some arc, and I'm just going to make this up, right? This is theta coming up here. I have no idea what it really looks like. I do know that this is 18, and this is in meters, and that the arc length, is 27 meters. And my producer is telling me that we're going to have to change tape in a second here, so I'm just going to put this 27 meters, and I'll see you in a second.